안녕하세요.
Wonderful. So again, thank you very much for inviting us to join, and very happy that we're able to do so even through such remote setting. Rex and I are very pleased to discuss Vertiport standards and technology, provide an update on where we are on some of those standards right now. So by way of introduction, Rex and I both serve on F-38, which is the ASTM Unmanned Aircraft Systems Committee. I am the subcommittee chair for F-3803, which is organizations, personnel, training, and certification. But by nature of my professional background, Rex and I also run the Vertiport standard together. We first organized that standard in 2017 and have run through 5 separate balloting efforts for date, with our 6th revision that is entering balloting process right now. A couple of items to discuss related to that standard, and a lot of the challenges is some fundamental differences between how the United States and Europe and other nations handle the commercial versus private use aspect of vertiports, as well as the interesting forms and platforms that are available for vertical takeoff and landing aircraft that are so radically different and not commoditized the way helicopters are. One of the nice things about helicopters and heliports is they all kind of look the same now, but the eVTOLs are very, very different. And there's something to the effect of 600 different styles of eVTOL that are out there, and trying to create standards and harmonize that is turned into a much longer process than I think Rex and I envisioned. Next slide, please. Tapping into an ongoing development as well, much like Mr. Ganshu talked about, is what we call the Vertiport Automation Supplemental Data Service Provider Standard, which is an identified component of the UTM and PSU systems, where those outliers that Vertiport would contact and talk to the PSUs from there. Now, this was organized only last year in the summer. It was based on the completion of some NASA high-density vertiport automation software research and development that Rex and I participate in. We're going to talk about a little bit more about that later on in the discussion. It is aligned to our standard on the development. So if you think of it as the first standard is more hardware focused and the second standard is more software focused, that's how that relationship is. And one of the things that we're sliding into the Vertiport SDSP happens to be compatibility with some of the 3GPP release 17, which is due this quarter of this year. Next slide, please. And last on this, on the standard side, is F-39, which is our Aircraft Systems Committee, is developing a practice for autonomous aviation systems. And one of the things that we've discovered is we need to work and link all 3 of these standards together, so that as we evolve simplified vehicle operations and more of the advanced aircraft themselves, and start separating functions away from pilots and operators and into electronics and automation, that we have them connected, and some of that broadening of the autonomy, in fact, goes to the infrastructure like vertiports as well. Next slide, please.
Thanks, Jonathan. As Jonathan said, we've been working together on the ASTM process for almost 5 years now this summer. So it's not something that we just started yesterday. One of the other complementing efforts out there is in fire code, and that's one of the areas that I specialize in. So the National Fire Protection Association, also known as Nfpa, has adopted standards in over 50 countries. There is a current Nfpa 418, which is heliport standards. In the last iteration, we actually added vertiports as a term, as well as vertistops. And that was published in January of 2021. As soon as that was published, we immediately opened up the discussion to move forward to advance fire standards for eVTOL aircraft. And in doing so, we reduced the time that the 418 standard is normally revision cycle. We went from 5 years down to 3 years. And what that meant was we started immediately in 2021 of April in advancing this next generation of eVTOL standards. It will live in NFPA 418. We've had several meetings over the 2021 summer, and now moving into 2022, our next major meeting will be in April. We have 5 days scheduled the end of April, plus 2 additional days the first part of May. We received 88 public inputs, which I think is a record for NFPA. I'm not 100% sure, but out of that, we're going to then publish the next post draft in October of 2022. That then opens up public comment period. That closes in January 2023. And then the second draft will be posted October. And then in 2024, we're looking for a final document with potential adoption by 2024. So NFPA, National Fire Protection Association, is recognized by the ICC, that's the International Code Council. So International Building Code and International Fire Code both point to this standard. And one of the key elements we're working on in this with ASTM as everything else is harmonization and trying to make sure that everything we do is harmonized across the board to the maximum degree possible. Here in the United States, the Federal Aviation Administration has been working diligently to begin the process of developing standards for vertiports. We have heliport standards. The first heliport standard was developed in 1959 and has gone through several revision cycles since. The standard for vertiports will live in what we refer to as an advisory circular. The advisory circular is developed and published by the Federal Aviation Administration for U.S. adoption. That process started in 2021, and we expect to hopefully have a published advisory circular for vertiports in 2024. In the meantime, to provide guidance for any manufacturer who is able to get certification before then, the FAA will be issuing what they refer to as an engineering brief as a stopgap measure to address standards for eVTOL aircraft. This month, February, is what they have pointed to as the release date for an engineering brief. In March, the 7th of March at the Helicopter Association International's annual conference, which is called Heli Expo, we will have a industry meeting to review and discuss that engineering brief. On the 29th of March, the FAA will then have an industry day to then vet that discussion, and by June they look to publish their engineering brief. That will live and provide guidance until the advisory circular in the United States is then published. Another group that's also working in this space is EASA, the European Aviation Safety Agency. In June of 2021, they did publish draft document that talked about the eVTOL or vertiport design. That's the second publication, a proposed means of compliance with special conditions in VTOL. I included the website at the top of the page. You can then go and look at that. Now, EASA is also working with the International Civil Aviation Organization, ICAO, which publishes heliport standards under Annex 14, Volume 2. We're working with EASA and ICAO, again, to try and harmonize as much as possible. The other group in the United States is working very diligently in this space is the NASA, our National Aeronautics and Space Administration. You can download the information that I'll show and John will show from the website that I have there on the right side. In a white paper that was published last year, we looked at the different possible geometric shapes for vertiports, as well as all the different possible outlines of vertiports. On the left is a very standard, traditional straight throughput with a landing and takeoff area, the TLOF and the FADO and the safety area on either end with parking in the middle. The figure on the right is a larger design with 4 independent landing areas, 1 on each corner, and then surface parking in the middle. And looking at what that meant, one of the things we looked at was the wind considerations. In developing the white paper, NASA had looked at the different feasible approach and departure paths. For helicopter operations, and same for fixed wing operations, downwind operations are to be avoided. It's much more challenging from a performance standpoint and less controllability. So in evaluating the different wind conditions, we looked at what was possible, what was probable, and what was recommended as far as avoidance. These are just a few of the graphs from the white paper that was published. And then in looking at the approach departure paths and how they connected, the other piece was looking at what was the maximum possible throughput for traffic that we could potentially get. And in doing so, the 2 images in the middle are the ones that provided the highest throughput based on the mathematical calculations that NASA worked on in this particular case. These are what we would refer to as UML4 considerations. And now I will turn it back over to Jonathan.
Thank you, Rex. So as I had mentioned, NASA funded a high-density automated vertiport research project. And that project was composed of 4 different sections: a trade study, a concept of operations, a software requirements matrix, and then some additional actual software development pieces that have turned into the basis for our SDSP standard. And what they were really designed was taking a look at, as Mr. Ganchu had talked about, the existing UTM work and how vertiports came in, and the idea that if there are UTM corridors or UAM corridors for our eVTOL aircraft to be flying on and be deconflicted off of, at some point you have to enter and exit those highways in the sky. And we looked at that as the base model, and then using the UML4, we applied it to a high density concept of operation. And high density was defined as 100 or more takeoffs and landings within 1 hour at a single vertiport. And as we look at that and started to build that out, much of the things that Rex just described, the challenges to the real estate size and the spacing and even some basic, just fundamental geography really became apparent to us. I would advise anyone who can follow the link that we provided earlier, and you can actually download all of these reports in their entirety. And it's definitely a very good read, several hundred pages of concept, and I'm going to try to talk through some of that here. Next slide, please, Rex. So the meat of what developed was the vertiport automation architecture. And that idea was that the piece that belongs at the vertiport, and it really had two different sections. One part of that was what connected to the PSUs and on the outward facing, and the other part was more internal and identified the requirements there for how you would track parking locations, ground traffic, taxi departure, and then all the contingency and off-nominal items that would occur. Additionally, one of the items that we discovered that I know we're going to get into a little more related to the sequencing of approach, because oddly enough, with 100 operations an hour, that means something is landing every 30 seconds or less, or taking off every 30 seconds or less. And that requires much more maneuverability and optimization than merely accomplishing that 30-second timeline. Next slide, please. So on the VAS itself, really tied into some basic core services to enable the functions that you would then provide. not just the management of vertiport resources, what pads were available, what type of parking, what type of refueling, but also to make sure that everything that is occurring on the surface itself was actually following the guidelines and procedures that were in place. So that if there was an aircraft that was running behind, or if someone dropped their luggage or something to that effect, or the passenger slipped getting into the aircraft, that all of that was captured in some way and able to be fed both locally at the vertiport itself, as well as transported out through the SDSP to the larger system for the PSUs to take out of. Did tie into our hazard conditions and our risk. It did very much highlight the need for a good situational awareness, as well as some of the limitations and potentials of autonomy. And one of the following items about external stakeholder communications was that notification outside the facility itself in the interest of an incident or some type of contingency, whether that was firefighting or rescue or even assisting with people who are not participating in the eVTOL PSU network. Next slide, please. I think one of my favorite pieces as a former helicopter pilot and something of a instrument approach aficionado, or as Rex calls me, nerd. One of the things we developed out of this was this concept of a vertiport operations area and then the vertiport volume. And you see that depicted here. The vertiport operations area is that larger blue-purple sphere and disc you see in place, while the vertiport volume is really on top of the geographical location itself of the vertiport. And as we developed this, we realized that in order to get the sequencing you need, you really have to have the outer spacing consolidated and federated in a way that it didn't matter which PSU was being used. It didn't matter if they were participants or non-participants, that we could feed them in together. And we started developing this dynamic, not a straight-on linear departure and approach pattern like we traditionally see with modern manned aircraft and traditional aircraft, but we call it the carousel approach, where picture those initial approach fixes on the outer surface rotating in time and not just being a single spot, so that as aircraft are cycling in, they're kind of working through this pinwheel pattern before they make their final approach and then enter into the point in space and final visual segment. And as you can see depicted on the right, that final point in space and visual segment is where they would break off and land at the appropriate landing areas. And this allowed us that final infrastructure of vehicle communications. Should something happen, there have to be an immediate move from pad 5 to pad 1. We could do that at that point very quickly and rapidly. Next slide, please. On that larger connection of how all this works, again, our idea was it only adjusted everything with the vertiports and the vertiport SDSP, really only tied in on the on-ramp and off-ramp into the larger UAM and AEM corridors. And once you left the corridor and began approaching your vertiports, that was where the vertiport operations area really began. And you can see some of that depicted here. Because once you've left the vertiport and you're outside, as was depicted earlier in Mr. Ganji's presentation, that is where the traditional air traffic control and traditional or rather newly developmental PSU integration and UTM really takes over, and we didn't want to have a conflict there. Next slide. And these are more pictures of how that worked and some of the things that we put in place. We realized that it's very easy to optimize when everything is accomplished well and there are no questions or concerns or sequence. Once you start putting in the sequencing issues and someone falls behind, or there's some crosswind or other unexpected items on the surface or in the air, you really have to have a very robust system behind that in order to make everything continue working smoothly. It's very difficult to tell someone no in an emergency when they're attempting to land an aircraft that is only have a minimal hovering capability and is kind of transitioned and committed to landing at that location. Next slide, please. This is a larger breakout and kind of describes the information that is available out there. Our trade study was when we talked to industry and gathered information on how the the industry viewed the task of vertiport automation and where the ground truth and contemporary viewpoints were. We also, at that point, looked at the future work being done on the ConOps that were under development, and then started to develop that ConOps for how we would match where industry thought trade was, where the ConOps thought we were going, and what gaps we had identified in between. The final piece was the vertiport automation side, which you'll see a series of OV1s like I just described, as well as the systems views, all of which is available from the NASA site, as well as some systems-based or model-based systems engineering actual files that were designed to have that together. And as you can see, that now feeds some of the follow-on work, both with FAA, NASA, and how they're developing on the UTM, as well as NASA's additional ATMX and high-density vertiport discussions. Next, please. So that concludes our portion. Really appreciate you letting us speak. Very excited to describe this work. It was about 1.5 years of our work just on the NASA studies alone, and we're continuing actively. As Rex did mention, there are many things that are tied into this that are continuing, especially on the ASTM side. Very excited that the current ballot's going out, so that allows us to really focus in on the SDSP. Rex, do you have any closing comments you'd like to add?
No, thanks, John. There is a lot of work going on in the background. John and I are involved in quite a bit of that with not only ASTM, as I said, National Fire Protection Association. I'm actually the chair of 418 committee, and working with the FAA on several contracts, as well as NASA on a couple of other contracts. The one that John just got finished briefing was a stepping stone for the new one that just kicked off, which is automated air traffic control. So hopefully by next year, we'll have a brief on that as well. So thank you so much for the opportunity to speak to you today, and really appreciate everyone's time. Thank you.